It's
Why did it just go 3-2?
We're just starting it. What?
Let's do it, guys.
it's recording.
It's recording me?
Okay.
No, it's a screen.
Yes. I'm- I'll edit it. I'll edit the beginning. So if somebody is Hi.
Where's my blue
Guys,
highlighter?
I'll show you when we're done. I'll show you when we're done, okay?
I was confused. I wasn't paying attention.
All right, so let's look at, we did some proofs on segments, so we're going to take a look at today a couple proofs on angles. So let's start off with just some definitions that we already had, but will be incorporated into some proofs. First one is supplementary angles. Two angles whose measures have a sum of 180. Okay.
Because they don't complement.
Okay, remember, so these are definitions. So if I ask you what's the definition of complementary angles, that would be two angles or a pair of angles whose measure have the sum of 90 or 90, degrees is fine. Okay, so we had a ruler postulate in the last section, and I just kind of went through it really quickly because that's something that you learn very early on in elementary school about how you measure something lengthwise. If you have a protractor, we already did a little bit of practice with this in the last chapter. You always want to make sure that you line up, right, your vertex right in the middle of the protractor. Now, notice there's two different groups of numbers. So it depends. It depends on which way the angle is drawn. But you should be able to recognize, if you're looking at the acute angle, you'll look at the inside numbers here. If you were looking at this obtuse angle, ABC, you would look at the outside numbers, right? Okay. So we talked about in the last lesson the segment addition postulate. Now we have the angle addition postulate. Okay, so basically, if you have, so this is going to be a possible reason, okay, so when we think about the column, the reason column, this could be a possible reason that we would use.
So there's like an infinite number of things you can put the reason to call.
There are certain things, basically, that's why I try to highlight. If I started a list a couple years ago, but then it was kind of hard to keep, because some of these reasons we'll use over and over again. Sometimes we'll use them a couple times and then we transition and
Forget them.
No, we learn other theorems that can then be applied to make things shorter. So we always try to do, our goal is to try to get the proof done in we're not trying to go for as many steps, but as few steps as possible. Angle addition postulate. So if we have a point D in the interior of an angle, then basically the two adjacent angles add up to the big one. Okay, so if this is X and this is Y, then the whole thing is X plus Y. Okay? Now notice here has an equal sign, so we don't have angle addition with a congruent sign. It's with an equal sign. So if we know angles are congruent, we just have to switch it over to equals if we want to incorporate this postulate. Now, the first example we have is not a proof. This is incorporating that postulate, though. So angle 1 is 23. So 23 degrees. And then ABC, this entire angle here, is 131 degrees. So if you can kind of picture that. And then we want to find the measure of angle 3. Angle 3 is just pointing to this little angle in here. Okay? So we can see what? Angle 1, basically the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 all has to add up to 131, right? 1, 2, and 3 all combined is 131 degrees. We see that? So if angle 1 is 23 and angle 2 is how many degrees?
131.
Hold on. Okay. Angle 2 is how much? 90.
Oh, angle 2. Thanks a lot.
Okay. So measure of angle 3 is 131. Subtract 90, subtract 23. Raise your hand, Allie.
Oh, wait, 18.
18? We agree?
Yeah.
Okay,
I agree.
good. All right, good. Questions?
Why is that one so much easier? What's the point of the M? I still don't understand.
Measure.
Measure.
Okay.
Oh, got it.
Whenever I use the little m,
No, I just don't know.
yeah, that just stands for the measure. That's fine. If you don't want to have to write measure of angle 3 and you want to use an x or a variable in there, that's fine. You're more than welcome to use you still have to just recognize that the measure, the little m and then the angle, you use that when you use an equal sign. If I didn't put the m in and I said angle 3, you can only use congruent. Like I could say angle 1 congruent to angle 2 or whatever, but the measures are equal. It's just like with segments. It's just notation. All right, let's look at a proof involving the the angle addition postulate. So take a look. Take a look at first, what are we given? What are we going to prove? We have the statement, so we're going to have to come up with the reasons. The first thing, I'm going to mark angle 1 and angle 2 are equal to each other. Okay, so these two are equal. And it's, again, what you want to do is look at what are you given and what are you trying to prove. Now, I don't mark what I'm trying to prove because sometimes that can be a little confusing. I'll mark things as we go by, but notice here PXR and SXQ. Do you see those two angles? So that's what we're trying to prove. Sometimes if you want to use like a highlighter or something, you can also see. So this is the one angle, and then I want this one to be the other angle. Okay? So what do you...
kind of overlap?
Well, the one I highlighted in red and the other one's in purple. So notice what they both, they overlap and they share angle 3. Okay? Question, Corey.
If they're gonna have to be equal,
Yeah.
like, if they're it's easier, because we know that they have to be equal, then angle 1 and angle 2 are congruent, not the
Right.
same.
So,
We have to do the statement.
again, if it's helpful for you to put in some numbers, okay, like Gabby was asking about, can we put in some numbers? So you could say, like, maybe this little angle is 20 degrees and this is 20 degrees. So just, you know, here's 20, and then this is 30. So it makes sense that PXR would have to be 50 degrees, right? Those two added together. And these two also add up to 50. So you can clearly see that the angles are going to be equal to each other. But again, it comes into, that's where the step-by-step justification, and that's part of the proof, okay? So the first step, right, given,
I like that step.
that's the easy one.
That's my favorite step.
Okay. Now, in the beginning, I do give you points just for writing given.
Thank you.
All right, next one. Now,
Wait, you mean so you won't give us points?
when we get into the more difficult ones, because it's given that you should write the given. That's
Nice. Well
in the
played.
beginning, I do, and then later on, it's like, it's
We're gonna be doing this later on.
all first semester. Okay. Angle 3 is equal to angle 3. What does that look like? That's obvious, right? So this is reflexive.
Reflexive. Same.
Wait, so that's not even necessary.
Yeah, that's what I don't understand.
Okay. Sometimes we use reflexive property. We'll use the reflexive property more when we do congruent triangles and some other stuff. So the reason I put it in here, I'd say this is kind of an optional statement because the next one, what do we notice? We notice that we're adding the same thing to both sides. So this is addition property.
We should add.
Okay.
If you spell a word wrong, will you mark this?
No. Okay. So
If I spell given.
number 4. Oh, this is a little. These 2 lines are for both statement 4. It's not. Number 4 is not based on the previous statements. It's actually based on the picture. So when it's based on the picture, it's probably our angle addition postulate, because the same thing was true when we did segment addition. So let's just make sure angle PXR is equal to measure of angle 1 plus measure of angle 3. Yeah, that's angle addition postulate. And same thing for the second line here.
Is angle addition postulate the protractor?
No, angle addition postulate was the one where we said if you have 2 angles that are next to each other, they're 2 adjacent angles, they add up to equal the big one. Okay, and then, well, we already said, notice here's angle 1 plus angle 3, here's angle 1 plus angle 3, here's 2 plus 3. So if these 2 are equal to each other, we can say these 2 are equal to each other. That is substitution. Okay, questions on that proof?
I always forget. I always confuse prop.
Okay, so properties, let me just clarify. The properties, like addition property of equality, subtraction property of equality, that's when you are adding or subtracting something to the same side of the equation. The segment addition postulate and the angle addition postulate is when you have 2 smaller things equal to 1 big thing. Okay, that's the difference between the 2. Whereas here, addition property is you're adding the same thing to both sides. Okay, here we have 2 theorems. One is called the supplement theorem. One is called the complement theorem. So let's take a look at what that says.
I feel like it has to do with supplementary and
Okay,
complementary.
so there's a couple ways. Well, this one is very specific. The first one is not just supplementary angles, but something that forms a linear pair. Now, if you have a linear pair, they are supplementary angles. Now, some students don't remember that it's called supplement theorem. So we can actually abbreviate this theorem, and I'll show you how I would abbreviate. I would just write a linear pair implies supplementary. That could be like a way that you could write this in your reason column. So if you see a linear pair, you can automatically say that they're supplementary. Now remember what the definition of supplementary was? Measure of angle 1 plus measure of angle 2 equals 180. Okay, so you can kind of see how they can be used in a similar way. What else? Well, we also know if we have adjacent angles that form a right angle, then they're complementary. So if 2 angles, this one's not as easy, this one's form a right angle, this implies that they're complementary. Or if you remember that it's called complements theorem, then just call it complements theorem. Yeah, complement theorem just means the 2, so basically you have a right angle with another ray extending, so you have the 2 adjacent ones have to add up to 90. Okay, here's an example kind of using some linear pair, not complementary angles, but let's look at what we have. Angle, this is not a proof, this is just, let's solve. So angle 3 is x plus 20. So it helps to just go ahead and label. What do we know? So here's x plus 20. Angle 4 is x plus 40. Angle 5 is x plus 30. 6 is 3y plus 32. And angle 7 is 5y plus 12. Question? This is all given to us in the direction. So what can we see about all the angles involving x? They all
They all form linear pair.
Okay, so they all add up to 180.
How do you know that?
So 3x.
How do you know it's a straight
So,
line?
again, we're gonna
Assuming
assume,
that.
yeah, right, we're gonna assume in this case, unless it's otherwise noted, this, if it looks like a straight line,
It's a straight line.
we're gonna assume that it's a straight line. Unless they say for sure, or if it looks like it's a little bit off.
So,
but-
can you assume the bottom line is a right angle? Makes a
Could
right
you
angle.
assume, okay, so you cannot assume the bottom, because if you assume it's a right angle, it has to have that little box. Lines are a little bit different, cause we don't have, we don't have a notation to label it as a line, whereas for a right angle, we do. We have that little square, or the little box that we would have in the corner. So if it doesn't say that this is a little right angle here, we can't assume.
It's like
So we know that x plus 20 plus x plus 40 plus x plus 30 has to be equal to 180. And then also 5y plus 12 and 3y plus 32 has to equal 180. You good with that? So we add up everything. Let's look at the x's. We have 3x plus
90.
90.
Plus 180.
So what's x equal?
30.
30.
And then let's solve for y. So we get 8y plus 44 equals 180. 8y equals, so y equals 17.
Yes.
Okay, so if I'm looking for angle 3, angle 4, angle 5, angle 6, angle 7, we just plug it back in. I'll just take a volunteer once you plug them all back in. You have it, Ella?
For 3.
Okay. What do you get?
60.
60?
I got 50.
I mean 50.
That's what he meant. He meant 50.
50.
50?
Yeah, and then 70.
70.
And then 60.
You don't need degree signs. It's okay. And then how about angle 6 and angle 7, Sheena?
83 degrees.
83?
For
Wait, 80
for what?
for angle 6, and then angle 7?
Is
107? Wait,
That's not right.
Doesn't make sense.
uh-oh. They should add up to 180.
I got 97. I got 97 for angle 6.
Did I do? Oh, I know what I did wrong. I did 3 y instead of 5
Oh,
y.
okay.
I did that.
But you got the 17, so just,
Yeah.
okay.
Yeah, I did the same thing.
What do we get for for angle 7?
That's 83.
That's 80.
No.
No.
It's the other way around.
Wait.
Yeah, it is the other way around.
No. 6 is 83.
No. It's not the other way around.
No.
Oh my gosh.
Guys, what's going on here?
3 times 17
3 times 17 is 51.
That's 90.
plus
That's
32
That's 83.
equals 83.
Angle 7 is
So I was
83.
right.
No,
No, other way around.
You guys are confusing me. My goodness.
Look at the 6. It's 3y plus 32.
Oh, right.
Oh, right. Just
97.
Just smart.
It's 97.
I was
Yes, angle 6 is 97.
It's
And that angle 7 is 83.
No,
The
that's
opposite way around.
No, it's not.
That is.
No.
Because look,
You guys were laughing at me forgetting the first
No.
one's wrong.
No.
this one is angle 6, this one is 7.
Yes,
Oh.
you guys don't you understand that? Jacob?
Yeah.
That's what we're only about. And then I,
Yeah.
and then I fixed it. Hold up. I was right the whole time.
So angle 7.
I was
no,
right
so
with
you-
you.
Right here is angle 6.
Yeah, they
Yeah.
did it the opposite way.
That has to be bigger.
Okay, so
Just kidding. Wait, no.
angle 6
Corey, stop.
is 3y plus 32. We found out y is 17, right? So 3 times 17 is 51. 51 plus 32.
But angle 6 is bigger.
Yeah, angle 6 is supposed to be bigger.
Yeah.
Says who?
Stop it. Because it looks like it.
Oh, it looks like it.
No, but can I get a protractor out?
It doesn't matter what it looks like. Okay.
It's just solving for it. You don't know.
All right, next page. Next page, we have reflexive, symmetric, and transitive property make their appearance again. Okay? It just means that we don't have to make, in order to use these properties, because these are all of congruence, We don't have to switch back and forth from equals to congruent to use these. We can just do the congruent sign. And then we have two more theorems. Okay, the next one. These are theorems. Theorems, again, need to be proven. We don't take the time to prove all of them, but there are a number of them that we do. In fact, we're going to prove 2.7 just below here. So let's take a look. It says angles supplementary to the same angle or to congruent angles are congruent. Okay, so let's take a look. So let's say angle 1. Let's attach some numbers just as an example. Let's say angle 1 is 120 degrees. And let's say angle 2 is 60 degrees. Right? Okay, so these two angles are supplementary to each other. Now, let's say 2 and 3 are also supplementary. So if these two add up to 180 and this one's 60, there's only one option for angle 3. It has to be 120. So that's where, here's the abbreviation. Angles supplementary to the same angle or congruent angles are congruent. So, yes, that's an S. So they write their little abbreviation. It looks like an angle. I'll often write it with like a little apostrophe, so I'll write angles like that. Instead of the S inside. I'll say that's my abbreviation for angles. The book will do this. So it looks like an angle with a little S inside. If you want to abbreviate either one of these, they're fine. They're fine. It's just angles supplementary to the same angle or congruent angles are congruent. Then we have next we're going to do the complements theorem. It's the same idea. So just look at 4 and 5. Let's say angle 4 is, let's say, 30 degrees. Oops. I didn't mean to do that.
Is this still recording?
Yeah.
Who's recording?
It's recording for Michael. He had to leave for sports.
Yeah, really.
Yeah.
Okay.
Hi, Michael.
Hi, Michael.
No, he only sees what's on the screen. He can hear us.
Oh.
Not very much, though. Mostly me.
Remember last year we tried to do this?
Okay. So,
Michael Brandt.
He's in our class.
Oh, Michael Brandt. This case is like really.
Guess what? American Express has really great customer service.
okay. So, you know what, guys? You can do it on your own then.
No, this case, come on.
So, the complements theorem is very similar. Just complementary means they have to add up to 90. Let's say this is 30 degrees and this is 60 degrees. Okay, so these are complementary. So now what if I told you angle 5 and 6 have to be complementary? So there's only one option for angle 6 and it has to be 30. So basically it forces these two to have to be equal to each other. Okay, so let's take a look at proving that theorem. Okay, so I'm going to write in angle 1 and angle 3 are complementary, and angle 2 and angle 3 are complementary. Okay. Now, at the very beginning of this lesson, I reviewed two definitions. One was the definition of supplementary angles. The other one was the definition of complementary. What was complementary angles?
When they add up to 90.
Okay, so I'm going to write in measure of angle 1 plus measure of angle 3 is equal to 90. And the measure of angle 2 plus measure of angle 3 equals 90. Again, I have to use that little m because I'm using the equal sign here. And this is definition of complementary angles. Now, if they're both equal to 90, we can say angle 1 plus angle 3 is equal to a measure of angle 2 plus measure of angle 3, right? They're both equal to 90. So measure of angle
Can you
1,
repeat that? I don't understand that.
they're both equal to 90.
Oh. Okay.
So I can make this equal to this. What reason do we use there? We've been using it over and over. Substitution.
Throughout proofs, is that like the most common?
Substitution is used pretty often. Yeah. Substitution, no, can only be used when there's an equal sign. So we have to be real careful there.
So what is it when it's complement when you just don't get rid of the what's it called again? Congruent.
Congruent.
Yeah. What do you use like? Cause you remember how
You
we like.
cannot add with congruent sign. So you have
Oh.
to change it over to equals. Okay, there's only 2 more steps. What do we have to get rid of on both sides? What are we trying to prove? We're trying to prove angle 1 and angle 2.
Get rid of the angle.
Okay, get rid of the angle 3.
Transitive, right?
No subtraction.
I'm tired, shut up. Whoa, Cameron got sassy.
Okay.
I'm tired. Shut up.
Guys, please stop.
Yeah, I'm quiet.
I think we need to do assign seats or something in
No.
here because this is not working.
Can I have a seat when you do science seats?
Sure. Okay, what reason do we have going from equals to congruent? Definition of congruent angles.
Angles.
Okay, now, guys, once we prove something, now if you encounter this in the homework and you're using a proof, you don't have to go through this process. You can just go from here to here. And the reason is angles complementary to the same angle or congruent angles are congruent. That was what was it called?
Wait.
It was
would be
called?
two-step.
Right, it would be a 2-step proof.
Oh, because we already proved it over here.
We
So
proved it.
How would we do it?
Well, we wouldn't have to, we just did prove it. So now if you encountered,
We proved it.
if you encountered a problem where if you had complementary angles to the same angle, you could go right to this conclusion.
And it's the transitive.
No, it's the congruent complement theorem.
We're already at the end of this chapter?
Oh, no.
Yes, go ahead.
Can you scroll down for 1 second? No, no, no.
Oh,
There you go.
Sorry. You can go
Ready?
from 1 to 5.
And then the reason is that we just proved it now.
Is Casey, what should I go back?
Wait, so what should we just write 1 is given and then 2 is congruent?
Maybe.
Theorem?
Come on.